Hi friends, this is Alok from Hair Classes. Welcome to the second lecture on set theory. In the previous lecture, we had covered the introduction on sets, and now in this section, we shall be covering different types of sets we have. Now let's have a quick recap on different terminologies that we had used in the previous lecture, some important topics. The first one is cardinality. There are a lot many people who are confused with the term called cardinality. Cardinality is it's basically a very simple term. It means that the number of elements in a set is known as cardinality. So the count of elements in a set is the cardinality. Let's have an example. If we have a set called A in which you have red, blue and green, the cardinality of this set would be 3. And we can represent it as n of A is equal to 3. Now let's take a second example. If we have a set called B, and in that set we have TV, fridge, AC, cooler and fan, then the n of B would be 5 because we have 5 elements in this set B. Moving forward, let's talk about empty set or null set. So as the name suggests, a set that has no elements is called the empty set. Let's have an example. If I have a set of the dogs that have 6 legs, it's not possible at all. So A is a null set here because there can be no dog with 6 legs. Now let's talk about the natural numbers. If I want any natural number between 1 and 2, which is not possible because there's no integer between 1 and 2, so the set B would be considered as a null set. Now let's talk about different types of sets we have. The first type that we have is the finite set. Second is infinite set. Third is singleton set. Fourth, equivalent set. Fifth is equal set, and last but not the least is universal set. Now let's talk about these sets in detail. Now what is a finite set? As the name suggests, it has the number of elements that can be counted. So the collection of finite elements in a set. Let's take an example of it. If we have the set of numbers between 1 and 10, you can count, right? So including 1 and including 10, you can count the numbers. So set A here is a finite set. Now let's take a second example. If there is a set B which has the collection of consonants in English alphabet, you can count the consonants of English alphabet, right? So set B is known as the finite set here. Now let's talk about the infinite set. Again, it's self-explanatory. It says collection of uncountable elements. So the elements which you cannot count. Let's talk about a set of stars in a Milky Way. You cannot count the set of stars in a Milky Way. So if it is represented with set A, so the set A will be considered as infinite set. Here is the second example. If I have a set called B that represent all real numbers, so all real numbers, they exist between plus and minus infinity, so it's not possible to count all real numbers. So again here set B is the infinite set. Now let's talk about the singleton set. It is a set that contains only one element. So it's pretty easy and pretty straightforward. If you have a set of the current Prime Minister of India, it's Mr. Narendra Modi, so A is the singleton set. If I talk about a set that has the largest state in India by area, so there can be only one state in India which can be largest. There can be different parameters, but here I am considering a parameter area, so set of largest state in India by area would only be 1, so set B is a singleton set. Now let's talk about equivalence set. Equivalence set is basically directly proportional to the cardinality of the set. So irrespective of the order, irrespective of the type of element two sets contain, the cardinality should be same. So let's have an example of A and B sets. I have 1, -7, 20 and 55 in set A and 1, 2, 3 and 4 in set B. Then A is said to be the equivalent set of B. Let's take another example of A having cow, dog and goat, B having grass, milk and leaf. So the cardinality of both the sets are 3 here. So A is equivalent to B. Let's talk about the equal sets. Now, the two sets are said to be equal when A is the subset of B and B is the subset of A. Right? Because I have taken two sets, A and B, and I have said here that A is a subset of B and B is a subset of A, then A is equal to B. What does it mean? It means that the number of elements or the type of elements it has in A, it has to be same in B. Let's take an example of it. If A is equal to red, blue and green and B is equal to green, red and blue, irrespective of the order, we have the number of elements and the type of elements as same. So A contains red, B also contains red. A contains blue, B also contains blue. A contains green and B also has green element in that. So A is equal to B. Now let's take second example to clarify it. If A is equal to cow, dog and goat and B is equal to dog, goat and cow, then A is equal to B. Because A is the subset of B here, because all the elements of A is there in B and also all the elements of B are there in A, so A is equal to B. So whenever this type of situation occurs, you would say that two sets are equal to each other. Now let's talk about the universal set. Now this is the definition of it. A universal set is all the elements or members of any group under consideration. Let's talk about a certain group, a group of Bollywood stars, a group of players under 19, a group of Indian cricket players. So they have their own fraternity, they have their own groups. So if we talk about a single group, so we'll talk about the elements of that group, and if that group is considered, we will talk about the universal sets. Now universal sets, it has two parts. First is the finite universal set and second is infinite universal set. In the finite universal set, let's say I want a set of real numbers that are true for the numbers between 20 and 26. We are having a set of real numbers, so we are considering a group of real numbers. So A is equal to 21, 22 till 25. So that's the finite universal set because you can count those numbers and it belongs to a particular fraternity, a particular group of real numbers. Now let's talk about the infinite universal set. So again, I'll take an example of stars in the Milky Way because I'll consider a group of stars in a Milky Way. So Milky Way is again its own fraternity, a solar system fraternity. So if I say that X represents a set of stars in the Milky Way, the A would be considered as your infinite universal set. So that's all. And if you like this video, do like it and do subscribe this video and watch for next videos to come.